Hello children, how are you all? Hope so you are doing good. Welcome to a session on linear inequations. The concept belongs to class 10 ICSE. In this session children, we are going to solve the different exercises from the latest version of Salina publications, that is concise mathematics, and also we are going to solve some of the previous year questions as well. Clear children? So before that we are going to learn about the concept linear equations, how to solve a linear inequations, and also what are the different terms involved in discussion of linear inequations. Keep in mind children, it's a playlist involving different episodes of different concepts. Clear children? So welcome you all once again to my channel, that is Ignitemath ARP. Don't forget to subscribe, like, and share among your friends. Clear children? Let us not delay. Let us continue with the concept, that is linear inequations. Children, right? So now, what are the different symbols of inequality? You have studied about the equations children, correct? So now if I'm talking about the equation, x is equal to 2 means what? The value of x is 2 itself, nothing else. Clear? Say for example, you are solving a equation x plus 2 is equal to 4. You are taking this to this side, then x you equal to 4 minus 2, x is equal to 2. See here we are solving a equation. Clear children? This is an equation, but here in this concept we are going to discuss about inequations. So what are inequations? So these are the different symbols where we are using them to represent an inequation. Clear children? So now if I want to use this one, how can I use this one? See, for example, x is not equal to 2. X is not equal to 2 in the sense x can take any value, but x should not be equal to 2. Clear? So x is lesser than 2. See, x is lesser than 2. It is not even equal to 2. That is the meaning of the second symbol. Now let us study about this one. Here it says x is lesser than or equal to 2. X can occupy the value of 2 also, but the rest of the values are lesser than 2. Clear? So now when I'm speaking about this symbol, right? So x is greater than 2. X cannot be equal to 2 here, but the values of the x are always greater than 2. Right? So when I'm speaking about the last one, here it tells x is greater than or equal to 2. X can take the value of 2 also, and also it is greater than the value of 2. Clear? Understood? So now I'll just write one inequation over here. Look at this example. Right? So x plus of 2 is greater than 8 if I write. Clear? Right? So now this is the left hand side of the inequation, and this is the right hand side of the inequation. Right? So here, what is the value of x? Is it greater than or lesser than or equal to, greater than or equal to, or only lesser than? Right? So that I can get to know whenever I'm solving the inequation. So how to solve is my question. So to solve this kind of inequations, I need to follow certain rules. They are not so difficult rules. In fact, they are much simple rules which you can easily understand and adopt to solve the problems involving inequations. So now let us study what are the different rules to solve an inequation, children. Clear? Right. So rule number 1. On transferring a positive term from one side of an inequation to the other side, sign of the term becomes negative. I'll just give you a simple example so that you understand the concept clearly. So suppose if I have x plus 3 is smaller than or equal to 5. Now I want to find out the value of x. I want to solve for x. Solving the equation means what? Finding out the value of x over here, right? So now here it is a positive 3. on the left hand side. Clear, children? So I want to retain only x on one side. So this positive whole of positive 3 to be shifted to the other side of the inequality. Clear, children? So whenever the positive number is shifted from one side of the inequation to the other side, what happens? So according to the first rule, the positive 3 becomes a negative 3. If it is a negative 3 here, it becomes a positive 3. Clear, children? So I can write this one as x is smaller than or equal to 5 minus 3. Observe this sign over here, children. It was positive over here. Now when it is taken to the other side, it becomes a negative. So this is the very first rule and the simple rule. Very simple rule, children, isn't it? Yeah. So now second rule says that when transferring a negative term from one side of the inequation to the other side, sign of the term becomes positive. Just like the same example as the above one, but it's a reverse case in the sense of 2x minus of 5 smaller than or equal to 12 if I have, right? So what is the sign of 5 over here? Sign of 5 is a negative. Now if I want to find out the value of x over here, I need to shift this minus 5 to the other side. So according to these rules, whenever a negative term is taken from one side of the inequality to the other side, the sign will be positive. So what it becomes over here, I can write this one as carefully if you observe 2x smaller than or equal to 12 plus 5. Observe the sign again over here. So here it was a minus 5. When it is shifted from the left hand side to the right hand side, it becomes plus 5. That is the rule number 2. Very simple, isn't it, children? You have learned so many questions on this during the chapter equations. Clear, right? Linear equations, right? So now let us see rule number 3. If each term of an inequation be multiplied or divided by the same positive number, sign of inequality remains same. So what is the meaning of this? Look at this. So now I'll take a simple example. 2x is greater than 5. Now if I multiply this 2x with the plus 3, right? If I multiply this plus 5 also with the plus 3, it should happen, children, because whenever you are multiplying one side of the inequation or equation with a certain quantity, the other side of the inequation should also be multiplied with the same quantity with the same sign. Clear? So keep in mind here, with what number I am multiplying? With the plus number, positive number. Sign of this 3 is plus. Sign of this 3 is plus. That is the meaning over here. Same positive number. Then what happens? The sign of inequality remains same. So nothing will go to, okay, change when I'm talking about the sign of inequality. So you just multiply it. So plus 3 into 2x, it becomes 6x, and here 3 into 5 becomes 15. So nothing to do with the sign of inequality. So it should be kept as it is. Clear? Understood? Okay, same thing happens if you are dividing it. Say for example, 2x is greater than 5. Suppose if I'm dividing it by 3, I'm dividing it by 3. Sign of inequality should remain same, should not be changed at all. Clear? Understood? Okay, now let us see rule number 4. If each term of the inequation be multiplied or divided by the same negative number, the sign of inequality reverses. Okay, so meaning is, look at this example, children. Okay, so now if I have 2x is greater than or equal to 5. Now if I want to multiply this 2x with the negative 2, so I should do the same operation on the other side of the inequation also. Then what happens to the resultant inequation? So when I multiply the left hand side with negative 2, it becomes a minus 4x. Then when I multiply the right hand side with minus 2, it becomes minus 10. Clear? So how about the sign? Okay, it says that the sign of inequality will get reversed. So here it is greater than or equal to becomes lesser than or equal to. Very careful. So it becomes lesser than or equal to. See, the sign is been changed only in this case. Only in which case? Only when you are multiplying it by same negative number. Only in such cases. Only in such cases, sign of inequality will get reversed. Either you can divide also, right? Suppose if I divide, say for example, I will take an example over here. 2x is greater than or equal to 5. Suppose if I am dividing it by minus 3, suppose if I am dividing it by minus 3, what happens over here? It becomes 2x minus 2x by 3, because it is plus over here, plus minus minus, minus 2x by 3. Then I'll get it as minus 5 by 3. The sign of inequation should get reversed, in the sense now it will be like smaller than or equal to. Clear, children? Clear? Simple example, right? For example, I'll give you an example with a number so that you will understand it in a better way. Look at this, children, right? Suppose if I have 5 greater than 2. Now what I do, I'll multiply this with negative 1. So I will multiply this also with negative 1. Okay. So what happens? Minus 5, I mean 5 into minus 1, it becomes minus 5. 2 into minus 1, it becomes minus 2. Now tell me which is greater. We say that this is greater. See, sign of the inequation is getting reversed. Clear? Understood? So if you compare with some number, you find it, oh, such a simple rule it is. Okay, it's not so complicated, right? So simply they are telling that sign will get reversed only when they are multiplying by negative number or divided by negative number. Clear, children? Let's move to the rule number 5. The sign of each term on both the sides of the inequation is changed. The sign of inequality will get reversed. So I'll give you an example for a better understanding. Not much complicated rule, children. Very simple. Now 2x is greater than or equal to 7 if I have. Right? So I am not liking this positive number. Okay, right? So I want to take the negative number in the LHS. I want to take the negative number in the RHS. I want to change the number. Okay, right? So then it becomes like 2x and minus 7. Clear? So minus 2x and minus 7. Right? I have reversed the sign of both the LHS and RHS. Then also the sign of inequality will get reversed. Clear, children? Clear? So means what? Whenever you are changing the sign on both LHS and RHS, keep in mind you have to change the sign of each term of the LHS and each term of the RHS, then only the sign of inequality will also get reversed. Clear, children? Right? So now let us move to the next rule, that is, if both the side of the inequation are positive or both are negative, then on taking their reciprocals, the sign of inequality reverses. Right? So simple example, children. Okay, very simple, seems to be complicated, but it is very simple when I explain you with example. Right? So now what I do here is I will write it as 2x by 3 greater than, I can write it as 7 by 4. Clear? So now what I do, I will do the reciprocal on both the side. So when I take the reciprocal on both the side, what happens? 3 divided by 2x, and here it is 4 divided by sign, the same sign, 7. Right? Then also the sign of inequality will get reversed. Then also the sign of inequality will get reversed. It becomes a lesser than. Okay, I'll give you an example so that you understand with the number. Right? So now you have, for example, 4 is greater than 2. It is 4 by 1, 2 by 1. Now what I do, I take the reciprocal on both sides. So it becomes 1 by 4, it becomes 1 by 2. Now which is greater, children? 1 by 4 in the sense it is 0.25. So 1 by 2 in the sense it is 0.5. Tell me which is greater, 0.25 or 0.5. So obviously 0.5 is greater. So now can I write like this, children? See here. So it is greater than, first of all. Now its sign is reversed. Sign is reversed. Why sign is reversed? Because I have taken the reciprocal on both the side. Clear? Right. So now what can I conclude, children? Can I conclude that when and all sign will get reversed? Sign of inequality. So sign of inequality will get reversed when, children? Only when, only when, first thing, multiplied, both the side of the equation multiplied or divided by negative number. Both the side of the inequations are multiplied or divided by negative number. And the second case, each term, sign of each term, I better write it as, okay, the sign of each term on LHS and RHS are changed in the sense reversed, I can say, right? Positive will become a negative, negative will become a positive, reversed. Then also sign of the inequality will get reversed. Okay, and the third case, children, can you tell me? Okay, when I take the, when reciprocating both the side of inequality. Okay, so both the side of the inequality, the sign will get reversed, sign of inequality will get reversed. Clear, children? Okay, right. So only in these three cases the sign of the inequality will get reversed. Otherwise, please do not change the sign of inequality. Be very, very careful. This is the only one point where many of the children go wrong and end up getting a wrong answer. So need to be very, very careful. So now let us study the next concept, that is replacement set and a solution set. Right? So what is replacement set? The set from which the value of variable x to be chosen is called as a replacement set. Right? Say for example, now I'll take example. Okay, always you understand the concept with the example, you feel it easy, right? Okay, now I will take one example. X plus 4 is smaller than 6. Then what is x? I want to retain x, so I will directly shift this 4 to the other side. Whenever positive number is shifted to the other side, sign of the number will be opposite, right? So smaller than 6 minus 4, I can write x is smaller than 2, I can write. Okay, so x can be smaller than 2. From which set I have to take the value of x? Is x a natural number? Is x an integer? Is it a whole number? Is it a real number? So from which set of numbers I have to choose the value of x? That becomes the replacement set. So here I would say if x belongs to natural number. Clear, children? Okay, so this set of natural number becomes the replacement set. This is nothing but the replacement set. Okay, so now x is lesser than 2 I have got. Then tell me please, what are the different values of x can take over here? And you have to choose the value of x from the set of natural numbers. So what are the values of x here? X can only be is equal to 1. Correct, children? Okay, so what is value of x over here? So I can say the different values of x which will satisfy this inequation, but those values should be taken from the set of natural numbers. Then the set containing such values is called as solution set. So solution set over here, tell me children, x should be lesser than 2 and it should belong to natural number. So can I say there is only one? It is nothing but the solution set. Clear? Clear? So for the same, if I have x belongs to the, see, x is smaller than 2, x belongs to the set of whole number, then this w is nothing but the replacement set. Okay, this is a replacement set. Now can you tell me what is solution set? Can you frame the answer in your mind? I'll give you some time. Yes. right? So value of the x should be chosen such a way that it should be lesser than 2, and the value of x should be chosen from the set of whole numbers. Means what? It should be the subset of the whole numbers. That's the meaning over here. Replacement set and its subset whose elements satisfy the given inequation, okay, is called as a solution set. Now can you tell me what is solution set over here, children? So x is smaller than 2. What are the numbers which are smaller than 2 and belongs to the whole number? See here on the number line you have 0 over here, 1 over here, 2, 3, 4, right? So here onwards, if I'm talking about this onwards, here onwards it is a natural number, here onwards this is whole number. Clear? So if you take on either side of the 0, that becomes the set of integers which are represented as I or z. Clear? Now can you tell me the solution set for this inequation now? Yes, right. Yes, you are right. It is 0 and 1. Clear? Clear? So now suppose if I write that x is smaller than or equal to 2 and x belongs to the set of whole numbers, then again here this is nothing but the replacement set. This is replacement set. Then what is solution set over here? Solution set should be subset of whole number. Clear, children? It should be 0, 1 and 2. Please can you tell me why I have taken 2 over here but why I have not taken 2 over here? It all depends upon the sign of inequality what I have. Clear, children? So here it says that it should be lesser than 2. It should not be equal to 2. That's why I did not include 2 over here. But here it says that x is lesser than, okay, or equal to, lesser than or equal to. That's why I have taken 2 as well. Clear, children? Okay, so very simple, very simple, children, right? So now what are the different methods of representing a set? Okay, this is nothing but a set. How do you define a set? Set is a collection of well-defined objects, you say, right? In your lower classes you learned what are the different methods of representing a set. Now let us discuss about methods of representing the set in a very short way. Clear? So the first method is a rooster method, or it's also called as a tabular method. What is rooster method? I'll give an example, children. See here, x is smaller than 2. Okay, if this is the inequality, then if I want to represent this set, right, so the solution set of this set, then I need to represent this one with all the numbers inside. Okay, so now this is if x belongs to the set of whole numbers. So here just previous example I'm taking it here. See, so I can say 0 comma 1. I am representing each and every set, okay, each and every number of the set, right? So what are the different prime numbers which are lesser than 10? So I can say 2, 3, 5, 7. These are the prime numbers lesser than 10. So I'm rating each and every element which satisfy the given statement. So that is called as a rooster method or tabular method. Then what is the rule method or set builder method? Okay, say for example, I'll just take the same example over here, this inequation if I want to take. So now I want to write this inequation in the rule method. So I need to have certain rule over here. So the solution set contains, the set contains x, where x belongs to a set of whole number. Okay, set of whole number, and x is smaller than 2. See, I'm writing one rule over here to define the set. Clear? So for this, okay, if I want to represent it in the rule method, then I would say x such that x belongs to the natural number and x is a prime number. Okay, prime number lesser than 10. x is a prime number lesser than 10. See, I'm writing a rule for that. Clear? So that becomes a rule method or set builder method. Clear, children? And the next one is a description method, which you don't use much in this lesson. You don't use at all. Okay, what is description method? You are describing whatever the set represents. Say for example, here a whole number, you are writing the description about the nature of the elements. Whole number lesser than 2. You are describing the set. Okay, in the other example, if I want to take a prime number lesser than 10. Okay, I can say more specific, a positive prime number lesser than, okay, 10, or a natural prime number you can say instead of positive. That is also well and good, nothing wrong, right? So these are the different methods of representing the set. Clear, children? Okay, now I think if I take one example, you will understand it in a better way. So before that, I will tell you a very important thing, children. Very important thing, right? Very important. Most of the children will confuse at this point. Okay, so if replacement set, okay, if replacement set is natural number, integers, or whole numbers, you are writing the solution set in the rooster method. Okay, so if replacement set is a set of real numbers, then you are representing the solution set in a set builder method, or which is also called as a rule method. Very important. Okay, very important. If the replacement set is a set of real numbers, then the solution set should be written in the set builder method only. If you write it in the rooster method, your answer is wrong. Is that clear? You will understand it in a better way if I give you an example, isn't it, children? Okay, let me take one example over here. Okay, so now see, let the given inequation x is a smaller than 3 I have here, correct? Right. So if the replacement set is a set of a natural number, okay, see here on the number line, children, 0 is over here, 1 is over here, 2 is over here, 3 is over here, 4 is over here. It continues like this. Okay, -1, -2, and -3. X should be lesser than 3, but the value of x should be chosen from the set of natural numbers. So means what? This set of natural numbers is the replacement set. Then what is the solution set? See, natural numbers will start from here, correct, and x should be lesser than 3. So can I say x can occupy only 1 as well as 2? Understood, children? So the solution set is 1 and 2. Now, if the replacement set is set of whole numbers, and again x is smaller than 3. So, as I told you, whole number starts from here. Okay, these all are whole numbers, but the condition is what? You have to choose a whole number such a way that it is smaller than 3. So, what should be the different values of whole numbers over here? Can you tell me, children? It can be this number, it can be this number, and it can also be this number, because it should be lesser than 3. In between 2 and 3 there are no whole numbers at all. Soon after 2 it is 3 only, next whole number. Isn't it clear? Right. So now that is the reason why I am taking it as 0, 1 and 2. Now if the replacement set is the set of integers, okay, integers is represented as I or Z, right? So on the number line it should be lesser than 3, right? It should be lesser than 3 in the sense what, children? It can be any number on the left side of the 3, but it should be a whole number. It should be a whole number, right? So I can take just lesser than 3. I have 2. Okay, so I can take 2, then I can go ahead with 1 0 minus 1 minus 2, it goes till the infinity. The condition is what? It should be lesser than 3, but it should be a the set of integer. So it goes on over here till infinity. This is how you are going to represent the solution set. Now comes a very important thing. If the replacement set is the set of real numbers. See, over here, in this case, as well as in this case, as well as in this case, I have represented the solution set in the rooster method. Okay, I have represented the solution set in the rooster method. Now, since the replacement set is set of real numbers, since the replacement set is set of real numbers, which is represented by the letter R, as I told you in the previous case, the solution set should be written in the set builder form. Clear? With a condition, with a rule. So how do I write that one? See, look at this. So solution set is going to be, this is nothing but your solution set. How do I write the solution set? X such that, how do I read it? X such that X belongs to, okay, I can write it as belongs to the set of real numbers, and X is smaller than 3. There is a rule which to be followed. Clear, children? This is how you are representing the solution set if the replacement set is set of real number. Rule to be followed. Rules are very important in life, children. If you are following the rule, you are falling in place, you come up in life. If you want to break the rule, then you will not be according to the rule. Means what? You are going in a different path. You may not achieve what you want to achieve. So follow the rules. Okay, don't try to break the rules. So here, don't try to break the rule of a rule method when you are representing the solution set, when the replacement set is set of real numbers. Okay, so whatever we have discussed till now, it is more than sufficient to crack all the questions of the exercise linear inequations. We are going to attack the exercise in the next session. Till then, take care. To be continued in the next episode. Yes, children. Bye-bye.